In this section, we're going to go over things that you need to think about before you start doing any of your test automation. What we're going to go over is how to plan for automated testing. We're going to figure out what you need to do in order to choose the correct test automation tool. Then we're going to look at developing code for automated testing. And finally, we're going to talk a little bit about strategy for automated testing. Let's take a few minutes to talk about how to plan for automated testing. So first, what are your goals that you want to solve with automated testing? Typical goals include reduce manual testing, and that includes using test automation to perform regression, to perform browser support. So instead of just testing one browser, you can test multiples or all of them if you really wanted to. And also testing browser support size or responsive design. So instead of just testing at a full screen desktop, you're able to test at half screen or smaller to kind of emulate what a real user might do. Another goal might be you want to release faster. Testing takes time, and the larger your product is, the more regression tests you have, which means that the longer you have to test. So automating testing would allow you to test faster, and thereby letting you release faster. Another goal would be continuous testing and feedback. So this comes into play with continuous integration. There are ways to set up your test environment so that you can run your tests every time a developer checks in code, or every time they deploy to an environment, or at different cadences. But automated testing gives you the ability to test and retest things as much as you want and give you feedback of the results of each of those. So let's take a moment to think about what should not be the goals that you want to solve with automated testing. What things are not realistic when you're trying to plan out what you want to test. First thing I mentioned here is find 100% of the bugs. So I think finding 100% of the bugs through testing is never going to be a realistic goal, whether it's through manual testing or through automated testing. The only way you can find 100% of the bugs is if you're able to create 100% of the test cases and execute 100% of the test cases. But as we know, that is probably never going to happen because things are constantly changing in the world. So browsers constantly update and change, which could cause a bug. Software is often changing. Dependencies are changing, and the way the users are using it may change, right? And these are all things that once you find them, you can write a test case for them, but until you know about what you need to test and how, there's not really a way to find 100% of the bugs before it ever gets released. And the second thing that I'm going to mention here is automate 100% of all tests. So your goal, it's okay to have a goal that I want to automate 100% of the tests. That's fine. If you achieve that, that's amazing. I have seen I don't think I've seen a company yet that's been able to automate 100% of the tests. But if you can do that, that is amazing, and congratulations to you. But most people are not going to fall into this bucket. So there are going to be reasons why you cannot automate 100% of all the tests. And there's also reasons why you shouldn't automate 100% of all the tests. But we'll get back to that in a bit. So what tasks are required in automated testing? So when I say task, I mean what are the daily things that somebody who's writing automated tests needs to be able to do So the first thing is write test scripts. So when I say write test scripts, that means either you're using code and you're writing an actual script that executes a test, or you're writing some sort of using a tool that allows you to write test scripts without the use of code. In order to write the test scripts, you have to take time to understand the requirements. So writing test scripts in automation is going to be kind of different from writing test cases for manual testing, but it's going to be very similar at the same time, because just like writing test cases, you have to understand the requirements so that you can write a proper test case. Doing the actual writing of the scripts, that's going to take time. And then validate that the test scripts work and update as needed. So it's kind of like a cycle. You're going to write your test script out, you're going to run it, and you're going to make sure that it did exactly what you wanted to do. Oftentimes, you're going to write a test script and it's not going to 100% do exactly what you wanted to do, so you're going to have to make little adjustments in order for it to do what you're expecting. The next task is that you are going to have to review the test results. Test results are going to be output every time you run your automated test scripts, and if everything is passing, then you don't have much to review because everything is working as expected. But if things are failing, you need to figure out why it's failing. There are typically a couple reasons why things fail. Number one, the application has changed and you have not updated your test script to accommodate for that, so you need to update your test script. So that's not really a bug, that's a test script maintenance issue. Another thing is that there's actually a bug, so there's something went wrong and you need to file a bug and take the time to do that. So as I mentioned, determine what the failure was. Fix broken tests. So that goes with the first scenario where the test is broken because the test script needs to be updated. And then open bugs on broken features. Alright, so the final task that's required in automated testing is to maintain the test scripts and framework. So I've been talking about this the whole time, that you're going to have to maintain your tests. So things change, so the test is going to be needed to be updated. The amount of time or the number of times that you're going to need to update your tests kind of depends on how much the application changes. Obviously, when you're writing new test scripts, I'm going to bundle that under write test scripts, but when things change that relate to other things that you've already written, then that is going to be part of maintenance. And then I also put in framework here because the frameworks that we use are also updating. So sometimes when you're updating to a new framework or a newer version of the framework, for whatever reason, the way you wrote your tests may need to change a bit. Usually they don't make it very drastic where you have to just start from scratch and do everything over again, but you may need to accommodate for those changes. Or there may be a new feature that you want to add into your existing tests that are available in the new version of the framework. Alright, so as I mentioned, update test based on changed functionality, and then update test based on updates to the framework. Alright, so here's the question. What are you going to automate? So here is the testing pyramid for as relates to automation. You've probably seen this before if you've been in QA for a while and are looking into automation, but let me break it down a little bit. So it's a pyramid. So basically the bottom section here is unit testing. Unit testing is typically done by developers, and it is testing that is done on kind of like the function level. So developers write functions that do specific things, and developers write tests that will test those functions, and these are built into their process. So when they do their integration or they check in code, these tests should automatically run and test their functions. So unit testing is important because they are the easiest to write as compared to these other two layers here, and they are the fastest to execute. You can run probably hundreds of unit tests depending on how complex they are, and in just like seconds sometimes, or a minute or two. But unit tests are very super fast and very specific. So the reason why unit test is on the bottom with the biggest chunk here is that unit testing should be the biggest chunk of software test automation. So even though developers typically write the unit tests, there's no reason why a QA would not also write unit tests. If you have the ability to do it and you want to do it, you should go for it. It's a great skill to have, and also helps you understand the code that you're working with better because you've tested it at that lower level. But as I was saying, this bottom section is the biggest here because that should be the bulk of what your tests are, because it gives you the most value. It gives you pretty much immediate feedback. So before the developer is even allowed to check in their code typically, or release to an environment, depending on how they have their CI set up, the unit tests will run and make sure that everything works before it gets released. So this saves a lot of time because deploying to environments takes time. It can take like minutes to like 20-30 minutes or even longer, depending on how complex the deployment is. But if you stop the deployment early on, then the developers can fix stuff and you can continue on with what you were doing and not have to stop and prepare to test an environment that is going to be faulty because it has failed unit test. Okay, so the next chunk in the middle is for services. So these are going to be web services, API calls. So these are going to be kind of like an integrated environment. So this is all of our back channel stuff. So let's take a web application, for instance. So a web application has kind of like, we can split it up into three things. We can say the front end, which is the graphical part that you see on the web browser. So all the buttons and menus and pictures and everything. So that's the front end. The middle layer is going to be the services. So these are going to be like your APIs that are communicating. So it's the front end uses the APIs to communicate to the database, and the database is that other level. So front end graphical part, services in the middle, and then database on the back bottom side. So services are going to be the next section where you want to kind of spend a lot of time in creating test cases for, because once again, services are very fast to run. For instance, I have one suite that has over 100 test cases, and the whole suite runs in in about like a minute or two. Sometimes it can run faster or slower. That depends on like network latency and like how complex things are behind the scenes, but a minute or two for 100 test cases is pretty amazing, especially when they're going to be more of an integrated environment. So services are also going to tell you things like, excuse me, oftentimes like on the front end, when you click a button, like a submit button, it's making a request to that service, and then it is going to make a request to the database and then come all the way back and refresh the screen with like, success, we did something. So if you test the service and the service is not working, there's no reason to test the front end, because if we know the service is not working, there's no reason to test the front end, because we know the front end is not going to work either, because the front end depends on that service. So that's why it's very important to kind of focus on the services when you're doing testing. They're going to be not too difficult to automate, and they run super fast, and they can just be run all the time. And then the final layer up here is the UI. So the UI has the smallest piece up there. So it's kind of a funny pyramid. So at the bottom, unit tests have the biggest chunk because they're the easiest to write, but they're probably the most valuable. Probably one of the most valuable ways for us to do automation. So time and effort versus results, right? So time and effort, unit tests don't take a lot of time and effort, but they give you a lot of results for that amount of time. Services tests take a little bit longer than unit tests take to write, but they also don't they also provide great results, because you can write lots of service tests in a short period of time, and it gives you a lot of bang for your buck. The UI, on the other hand, the UI is going to give you the least amount of kind of reward for your effort. So the UI tests are the most complicated to write, they're most complicated to maintain, and they're the longest to run. So sometimes, like, a single test case can take like 2 to 5 minutes or more, depending on how long it takes for it to get from step A to step Z. Okay, so that's why the UI is up there at the small part, because we have a lot that we need to test in kind of a short period of time. So but we have so much effort that needs to go into to build, maintain these UI tests, and the value of it is not as great as what you would get from unit or service tests. So, but I'm not saying that UI tests are not important. So UI tests are very important, but you are going to want to focus your effort on the UI tests. So typically, I try to focus UI tests on things that might only happen in the UI. So that's going to be primary. So making sure an error message displays on the screen. That's only going to happen in the UI. You're not going to get that in the service tests. And going through certain workflows is good also. Testing for browser support, testing for responsiveness, and then and some basic functionality. So for example, you have a search test. So you can search for somebody and then make sure that you get the result. Probably one search test is good enough, or one or two, depending on what you're doing, how complex your search is. But if you're looking for the output of the results, I would stick most of that effort into the services, because you can write like a million, like not a million, but 100 search tests, like super easy in your service, and it'll return really fast if you're just looking to see that the search function returns the data. And from the UI, you're trying to see that the search, when I type in the search field and I click the search button, and then it displays the search data. So it's very specific to what you want to do. All right. Okay, so I'm going to move on from here. So who is going to create the automated tests? So we have kind of 3 tiers of people. So test engineers. Test engineers, they may understand the testing aspect of writing test cases, but they may or may not be proficient in coding or DevOps. And if you don't know what DevOps is, it's related to like build and release and all that stuff. So DevOps is important when you get to like the CI/CD, continuous integration and deployment part. If you're not there yet, then don't worry about it, but kind of focus on the coding part more. The second person who could write automated tests are the developers. So developers understand coding, but they may not be proficient in DevOps, and they may not be proficient in testing. So as we know, testers are great at testing, coming up with test cases and doing all that stuff. Developers are great at developing, but the two don't always do a great job at doing each other's job. All right, but you have a third option. So there's an automation engineer. So typically this is called either an automation engineer, or it's referred to as software development engineer in test. So, or an SDET. So software engineer in test is kind of a combination of both that test engineer and developer. So I would kind of think it as on your career roadmap, as you go from a QA, you're going to start as a test engineer who's doing like strictly manual test cases, writing stuff. You're kind of growing, learning how to doing all the testing stuff, but then along the way, you're learning how to code. So learning how to code, understanding the development process more, and then you move on to more of a SDET position where you can do testing through manual. You know how to do all the basic manual and test stuff that QAs do, but then you also know how to write code to make your testing more efficient. So you have to figure out who is going to be doing that testing on your project. So these are your three options. And let me continue here. So I'm going to say, but really, who is going to create the automated tests? So this is kind of a pain point. So I've gone to many companies, and there's always like companies that are hiring out there that are like, oh, we want somebody that knows how to do automated testing and this and that, and kind of when you're reading that, you're thinking that, oh, they already have automated testing in process at their place, and you want to go in and help them build up and continue what they're doing. But I find more cases than not, that is not what is happening. They're asking for an automation experience because they have no automation at their place. So the company is looking for somebody to build up and run that automation. So that means they are not in a place where they have made automation a job or a role, and it's kind of like a stretch goal, right? So they haven't had it, or they're trying to hire you because they want to make automation the role, and they don't want it to be a stretch goal anymore. So who's going to do automated testing? So priorities. Test engineers are pretty busy doing testing, doing all that stuff. Do they have time to do automation also? Do they have time? So if we're talking about those three groups of people, so the test engineer would have to either learn a framework to do testing without coding, or they would have to learn how to code, all while doing their job as a test engineer. So which is more important, getting this priorities done, or getting this test engineer trained up so that he can do the automation? Developers, on the other hand, they're building code, they're building features, they're rolling stuff out. Do they have time to, once again, they have to figure out a framework to use for test automation, because they're probably not used to using one since they're doing development all the time and they're not using test frameworks. So do you want to pull them off of what they're doing so they can do some automation part-time, or make the developer an automation engineer kind of a person? But usually developers don't like that. They don't want to be turned into test people. There's like kind of like a stigma behind that. So that might be out. And then the test automation engineer, if that's his role, then that's all he should be doing. So that might be the best option for you, but do you have the budget and resources to hire somebody to do that? Or do you have enough time for one of your people to be a test automation engineer and kind of roll with it? All right, so I kind of already talked about time. So do we have time? So priorities and time, they kind of go together. Like what do you need to do, when do you need to do it, all that stuff, and experience. So I think all these things have been covered. just a final bullet point. This is not a part-time job. So automation engineer, as I told you, write scripts, maintain scripts, analyze results, and fix things. So you're going to be doing stuff every day. It's not a kind of set it and forget it kind of job. You can't just create test cases and then just let it run forever and hope, and then just write bugs for things that go wrong. No, you have to continually keep an eye on it and maintain it as time goes by. Okay, so some keys to successful implementation of test automation. Okay, determine your goals. So that's what we're doing here. We're trying to determine what is feasible. Ensure the correct people are assigned. So remember those three groups, like who do you want to do the automation? Build test automation into your process. So remember, this is not a part-time job. This is something that needs to be done. One of your sprint goals might be that for a story to be called complete, it has to have automated tests. So that could, and you might want to break it down also. It has to have unit test, it has to have service test, and have to have the UI test, depending on what you want to do. All right, don't treat it as a side project. This is a full-time job. You cannot just do automation sometimes. You can, but it's not going to be very effective, and it's not going to reach your goals. There are a lot of tools out there for automated testing for both the services and for the UI front end side, and it's kind of hard if you're just coming into this brand new to determine what you want to use as a tool. So let's go ahead and talk about that for a second. Alright, so how do I decide what tools to use? Alright, so first, what needs to be tested? So as I said, are you just trying to test services? Do you have a company or do you have a project where you don't have any front end? You don't have any graphical user interface. You guys are just making services. So in that case, you wouldn't need a front-end automation tool. You would just need something that automates the service testing. And on the other side, if you have to do the front end, then you would need a front-end automation testing tool. If you need to test things for mobile devices, then you might need something different for that. It kind of depends on your needs. So you need to figure out what you need first. Alright, next thing is the code versus no-code tools. So I talked about this a bit in the previous lesson, but this kind of comes down to who is going to be doing the writing of the test scripts. So is it going to be the test engineer who doesn't know how to code? So if you have a test engineer that doesn't know how to code, then probably a code-based tool is not going to work too well for them, because they're not going to get very far, or they're going to spend a lot of time learning how to code instead of writing tests. And on the other side, if you're choosing a code-based tool, who's going to be doing it? Is it going to be the developer, or is it going to be a test automation engineer? So you kind of have to think about that. And kind of my feedback on, and probably most people's feedback on code versus no-code tools. So code-based tools are typically a few things. So number one, they're typically open source. So that means they're free to use. You can do with them as you please, and there's lots of community support out there to help you on how to use these things if you ever run into an error. No-code tools are usually not going to be free. So I think for the most part they are not free, and they are also very expensive, either as like a site license or a per user license, but these are very expensive. So kind of like the benefits of the code-based tool, which is kind of why most test engineer or most companies are looking for a test engineer or a test automation engineer or SDET who knows how to code well, because saving money, code-based tools are usually easy to integrate into other things. There's lots of documentation on it, and they are more flexible to do things easily as opposed to non-code based tools. All right, programming language. So my kind of philosophy is that if you're working at a web development shop, then you probably want to go with the JavaScript based testing tool or testing framework because you'll have QA or test automation engineers who can write in JavaScript, but then also the developers are writing in JavaScript, so they would be able to help with stuff. And there are just like so many JavaScript front end test automation tools out there for you to choose from. All right, I kind of already hit this one, open source versus paid. So obviously your company is going to be happy if you can do open source, but that kind of goes back to the code versus no code thing. I haven't seen very many, if any at all, that are code based that are not open source. There might be a few out there, maybe to get some like special features, but typically the code based ones are open source. All right, reporting. So all of the test automation tools should include some sort of reporting. Usually the code-based ones allow you to kind of choose which type of reporting that you get. So you have some flexibility there. The non-code-based ones are going to usually have just like one standard way of reporting, but you kind of have to see like what kind of information are you looking for to be reported back, and kind of find the tool that gives you what you need. All right, and integration support. So I touched on this a little bit, but being able to hook your test automation suite into other things like CI/CD pipeline, or into some of them can go directly into the test case management suite or into Jira to report out things, and so forth and so on. So being able to integrate that is often a important aspect of choosing a tool. All right, so here's just an example of some of the popular UI automation testing tools. So there's Selenium, Cypress, Robot, Protractor, WebDriver IO, and Puppeteer. When you're talking about web UI automation, people always just like kind of blurt out Selenium. Even people that have never done any sort of test automation at all, they're just like, yeah, just use Selenium. Selenium will solve all your problems. Well, Selenium is a library of for test automation of the web, and these other tools often contain Selenium in the back end. So WebDriver IO and Protractor are using Selenium. So if you're using one of these pre-built frameworks, then you're already using Selenium. So it's if you want to use Selenium, then you can do either or. With Selenium, you typically have to build out your own framework. So Selenium is just a library. It's not going to give you all the utilities that you may need and that are built into other frameworks like Protractor and WebDriver IO to let you do things easily. So you'll have to kind of build it from the ground up. So if you just want to use Selenium and make your own framework, then go at it. But you're probably going to need to be a more experienced at coding and understand how to do stuff and what you need, because you're going to have to fix your own stuff. And for the last slide here, so here's some API automation testing tools. Most of these are free, open source. There's kind of a mix in here. So some of them are strictly for testing the API services, but some of them, like Gatling, it tests the services, but it's more of a performance testing tool. So it's meant for performance testing those APIs. But if that's what you're looking for, then that's available and out there, and kind of choose what you need based on your requirements. All right, so let's briefly talk about developing for automated tests. So how do we develop code to help with test automation? So when I'm talking about developing code, I'm talking about the actual application code. So for the front end, it's very helpful if we have some sort of identifiers on HTML elements. In order to automate front-end web applications, we need to be able to locate buttons and links and text and whatever on the page. And if there's an easy way for us to do that and a reliable way for us to do that, then our tests will be few things. It'll be faster because more specific elements make the test run faster because it doesn't have to do a lot of searching. It just instantly finds stuff, and then it'll make it more reliable. So that way, if you move stuff around on the page or minor changes will not affect the test, and the test will still run without having to do extra maintenance. And number one, figure out why the test is not running, and then update all your elements that are affected by it. All right, accessible design. So I found out that when your website is built in a way that is accessible. So if you're not familiar with accessibility standards, it means that somebody with low vision or who's blind or who may have a hearing impairment or some other disability that keeps them from being able to use your website as would somebody else who doesn't have that disability. That's what accessible design is. So things like being able to tab through the fields and get to fields and type stuff in, being able to navigate through a table line by line so that they can get all the values from it, things like that. So I found that when sites are built to be very accessible, they're also easier to automate, partly because I think you have another option of accessing things. So sometimes I can't, I have to get to somewhere on the page, and I just want to use like the tab key or the down arrow or something, and then it'll pop me into the next thing, because it might be a dynamic element or for whatever reason. So having an accessible design really helps with that. Alternate paths. So by this I mean having a way, more than one way to get to somewhere. So think of this as like I'm looking for shortcuts. So if there's a specific page for buying roses, so I want to be able to jump directly to that buying roses page that I want, as opposed to having to go to the home page, search for roses, find the thing that I want, click on it, and then get to the page. I want kind of just a direct shortcut to be able to get there, because that'll make the test faster, and then it'll make it more reliable because I don't have to worry about steps A through B, A through C, and I can just go to step D and do what I need to do. All right, and for APIs, there's not a lot I'm kind of asking for when you're developing code, but test tokens are often a pain, or tokens are often a pain. So if you have a test token or a way for us to get a token, then that would be very helpful. So oftentimes, if you're not familiar with API testing or development, then oftentimes when you make a request for some information, you will need a token to prove that you are allowed to make that request. So these often expire, so you can't just use the same one over and over again. But if you have a way for the test engineer or whoever's writing the test automation suite to be able to generate a new test token on the fly and use it, or just have a static test token that they can always use, then that would help a lot with their API testing. Let's take a few minutes to talk about strategy for automated testing. So what are the key design aspects of writing automated tests? So they should be independent, and don't worry, I'm going to go through these individually after we list them all out here, so just hang in there. They should focus your test cases, plan for scalability, isolate test data, have reusability, follow good coding standards, have code review, and use source control. All right, so let's talk about the first one, independent. So what does that mean? So that means that the test should not be dependent on another test. So if you have two tests, so you have, let's say you have a login test and you have a test that does some sort of search on a page after you log in. So you should kind of bundle those together so that way if the login test fails, then your other test does not fail, if that makes sense. We want the tests to be independent of each other. So you should be able to execute any test at any time, and I'm going to say in any order. So let's say I wanted to only execute that search test, and I don't want to do the login test. So I should be able to just execute that search test on its own. It should do everything that it needs to do and provide the results that you need. Any setup or teardown should be included within the test. So, as I mentioned, everything should be as part of the test. All right, next is focus your test cases. Tests should focus on a very specific outcome. So, as I mentioned before, having multiple test cases, so if they're independent, then you're more likely going to be focusing on a specific outcome. So, for example, a login test should only focus on what happens when the user logs in. The steps needed to log in, verification of the results of logging in. Do not verify everything on your path, that should say path to your goal. So what this means is that if you have like 16 steps before you get to the actual page where you need to test, don't verify everything on the way from the beginning all the way up to where you start your test. You only want to start verifying the part where your test is. So your test might be to search for roses. So I don't want to verify that the login field is there, the password field is there, the submit button is there, that the submit button takes me to this page, that this thing does that, and this thing does that. I don't care about any of that. All I care about is that on the search page that I can search for roses and that it gives me the result that I was looking for. So very specific. So not focusing your test leads to redundancy. So why are you verifying the same thing 100 times? So imagine you have 100 test cases and 99 of them have to go through the same path to get to where the actual tested value is. Then you are re-verifying the same thing 99 times. So you wouldn't do that if you were manually testing it, and there's no reason to do it if you're automating the test. It's a waste of time, it's a waste of code, so just don't do it. So as I said, increase testing time. So every step takes a little time. And also lack of clarity of the failures. So if you are not specific on your test case, then what if step 2 of 16 failed an assertion? So if it failed your expectation. So let's say there was a typo on the login page that instead of saying submit, the button said enter. So every single test that is verifying that login button text is going to fail. So, but when you look at your report, it's going to say search for roses failed, search for butterflies failed, search for paper failed. So it's not going to be clear of why it failed. It just looks like everything is failing, and the actual reason of the failure is upstream because you're re-verifying something that doesn't need to be verified. All right, next one is plan for scalability. So your tests should be written in a way that they can be easily scaled. So what does scaling mean? So scaling means that instead of having one instance or one computer, or however you want to phrase it, doing doing some work, I want to be able to have multiple computers doing the work, or I want to be able to easily point my test from one environment to the other without having to rewrite tests specifically to do that. So they should be designed to easily switch environments. So you should not be hard coding the environment value or the URL into your test, because often when you're testing across multiple environments, a local environment, a dev environment, a test environment, production, staging, whatever you have. So you don't want to have to write specific test cases for each of those environments. You want to be able to easily swap out the base URL for those so that you can easily test it. Ability to run in parallel. So this is what I was talking about, being able to use more than one instance or thread or computer to run your test. What this does is this makes your test run a lot faster. So say you have 100 tests that in total it would take you let's just say 100 minutes to run if you did it from one single instance. But if you were able to split that by 2 instances, then obviously you're going to have, it's going to only take 50 seconds instead of 100 seconds. And then if you were able to split that even more, then it's going to go down and down and down until your tests can run in minutes instead of hours, or so forth and so on. So that's what it means to be run in parallel. Isolate test data. So test data should be isolated. So you do not want to share test data between tests that read versus read, write, edit the data. So let's take, for example, remember, you want to be able to run any test in any order. So let's say, for example, one test adds a new rows to the inventory, and then another test deletes that rows that you added from the inventory. So that breaks the first rule that we had about tests should not be dependent on each other, because the second test would fail automatically because that rows doesn't exist. But then also, if you have a test that is self-contained, so let's say add a rows and then delete it, but then you have another test that says I want to read the properties of that rows from the page using that same data, then you're going to have a problem. So try to keep your test data isolated. So if you have a bunch of tests that just read stuff, that's fine to share it. But if you have a test that is doing any sort of manipulation or editing, use different data. Use a different login, use different data set, whatever, and try to keep it just to that test. That test should own that data. Reusability. So when writing test scripts, you should take every opportunity to create functions for redundant steps. So make things reusable. So this is kind of like the dry principle in development. Do not repeat yourself. So you are going to do common things like login is a super good example of reusability. So let's say every test you need to log in before you can do anything. So instead of writing enter username, enter password, click the submit button, you can create a function that just says login, and then you pass in whatever values that you want for the username, password, and then it'll automatically just click the submit button for you. So you have reusability. Also, keep in mind the scope of your function. So if your function is something that is only going to be used for the specific test or the specific test suite, then try to keep it within that kind of area. But if it's something that can be shared, like the login can be shared across multiple test suites, then sure. And then if it's something even higher up, like creating a date in a specific format or doing some calculation of a random number or something like that, then you can have that like as a helper function, because those things aren't specific to any page or functionality. Those are just helpers to get you the data that you need in order to do your testing. All right. And then the other thing is, don't write assertions into functions. So assertions are basically your verification point. So it's like verify that the button says submit, or assert that the button says submit. It's the same thing. So that's what an assertion is. So do not write assertions into your functions, because as I said before, we do not want to be testing the same thing over and over again. So if that login function had assertions in it for make sure that the login field is there, make sure password field is there, make sure the button says this, then you're going to be running those assertions every time you use that function, and that's not what we want to do. Follow good coding conventions. So good coding conventions are not optional. So this is not just a good test automation thing. This is for like any sort of coding and development. So some things that should be included. Do not repeat yourself. So the dry principle. So if you can create a function out of it, do it. If you're seeing yourself writing the same snippet of code over and over again, that should be a function. Consistent indentation. So there are tools to help kind of like mitigate this, like Prettier or ESLint, something like that, but you should have a consistent way that your code looks so that it's easy to read, and so that it's kind of like has a standard way that it's written. Naming conventions. So you should choose how you name your variables, your functions, and all that thing, and kind of stick with it, because that way, like once again, it's easier to read because for other people, as if the convention stays the same. Code comments. So this is kind of always like a sticky spot. It's like developers love and hate code comments. They love it when there's comments there, but they hate writing the code comments because it's extra stuff that they need to do. But these are super valuable in test automation. Typically, my code comments I like to write out my test steps in comments before I actually write the code for them, because then you can see that it's like I wrote up my test case manually, basically, through code comments, and then within there I make sure that I did everything that I was expecting to do through code. All right, small file sizes or limit lines per file. So just try to keep your files small and contained. We don't want like one huge file with like millions of lines of code in it, because it's just kind of hard to manage. Merging and source control is going to be more difficult when you have so many lines of code in a single file, especially when you're working with other people, because you're going to have conflicts because you're all working off the same file. So just try to keep it as small and specific as possible, and just keep code simple. Don't try to be a show off and write some fancy code just because you can. Just do the thing that you need to do in the most simple way possible that makes sense. All right, code review. Make sure somebody is reviewing your code. So make sure somebody is doing a review, and they should follow these key checkpoints. So the test should run and pass. So that is bare minimum. So if the person pulls your code in, they push the play button, it should run and everything should pass. You should not be checking in failing code. Test expectations match requirements. So this is just making sure that what you are expecting to happen is happening. Yeah, pretty simple. And then good coding conventions. So we already talked about that. All right, so final thing here is source control. So determine a source control strategy and use it. So I've seen so many new QAs who are trying to get into test automation, and they didn't use any source control, and boom, they lost their hard drive or something, and it's just like they wasted like a couple weeks or months worth of work. And there's no reason not to use source control. It's free. You can use Git for free, or whatever your company provides you. If you're in a development shop, then you have some sort of source control. There's no reason why you shouldn't use source control. So just make sure you use it.
If you enjoyed this video, please hit the like and subscribe button. It would really help support this channel so that we can grow and bring you more awesome videos just like this one.